as far as the dividing square roots go, if you follow those notes that we took on Wednesday this week, step by step, you should be in pretty good shape. Okay, all of those things are things we've done in the past. We're just putting it all together to simplify square roots in fractions, so dividing square roots. In the first one here, the very first step we want to do is simplify the coefficients and simplify the radicands. So looking at the coefficients first, this 18 and the 2, can I simplify that? Yeah, in fact, not only can I simplify it, but I can actually divide it, right? So if we have a fraction and we can do the top divided by the bottom, you can reduce it if you want. Reduce by 2 and you get 9 and 1, right? Or you can just divide it, and instead of doing that, you can do 18 divided by 2 and get 9. So what we end up with is just a 9 on the outside. On the inside, we can divide those also, right? Yeah. So again, we could reduce it if we want by 5, or an easier way to do it would just be divide. 10 divided by 5 is 2. So we get a 2 on the inside. Now why is that 2 on the inside? Why is the 2 on the inside of the square root? Yeah, 10 and 5 were inside. So when we divide inside numbers, we get another inside number. All right, so that one should be pretty straightforward. If you had reduced instead of dividing, you would have gotten 9 over 1 here, and you would have gotten 2 over 1 here. And you'll see that when we have the 1s in the bottom, we don't really need those 1s because the square root of 1 is 1. 1 times 1 is 1, and anything divided by 1 is the same thing. So what we get is just whatever's on top. So when we end up with 1s after we reduce things, we can get rid of those 1s with one exception, and the exception is if it's alone in the numerator. If we have only 1s in the numerator, we need to put a 1 there still. In the second one, can I reduce the coefficients here? No, the only coefficient we have is at 15, right? Can I reduce the radicands? No, the only radicand we have is the 3. Why can I not reduce the 15 with the 3? Yeah, the 3's inside the square root and the 15's outside the square root. So since one's outside and one's inside, we cannot reduce them with each other. All right, so we go on to the next step, which we didn't have to do in the last problem. And that next step is the one where we actually get rid of the square root in the bottom. So I need to multiply by a square root over a square root. What am I going to put inside of those square roots? 3. Remember, they have to be the same. Okay, so I multiply by the square root of 3 in the bottom to get rid of this square root on this 3. But I also have to multiply the top by the exact same thing. So make sure that you're not multiplying the bottom by one thing and the top by another. All right, once we do that, we need to multiply it out and simplify. On top, can I multiply 15 times 3? Get 45? No. 15's on the outside, 3's on the inside. Okay, you need to make sure you keep outside numbers on the outside, inside numbers on the inside. So when we multiply this, we get 15 on the outside and 3 on the inside. We cannot multiply them together, so we just get 15 square root of 3. On the bottom, this is kind of a special case. If we multiply a square root by the same square root, what's going to happen? Exactly. We get rid of the square root, right? So we get the same number, but the square root's gone. And really what's happening is the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is 3. So if we multiply any square root by the same square root, then we get the same number, but without the square root. Okay, so that's step 2. Am I done? No. We need to do step 3, which says simplify, right? How can I simplify this? The 3 with the 3?
3 and 15.
The 3 and the 15. So this 3 here is on the inside of the square root, and this one's on the outside, so we can't simplify those. But the 3 and the 15 can reduce. In fact, kind of like the first one, we can actually divide those, right? 15 divided by 3 is 5. So what we end up with is 5 square root of 3. On this one here, what can we do before we try to get rid of that square root? We do not want to start this one by multiplying by the square root of 12 over the square root of 12. All right, that would get rid of the square root on the 12, but then it would also make things more complicated for us. So what can I do first? What's the first step? Simplify coefficients. We can't do that here, but what about simplifying radicands? Can we do that? Yes. So what can I do with the 6 and the 12 on the inside of the square roots?
You can both divide by 2 or 3.
4 or 6, right? So we could reduce by 2, we could reduce by 3, but the biggest thing we could reduce by is 6. And if we reduce by 6, that's going to cancel out the top completely, right? So when we reduce by 6, that's going to be gone, and this is going to be...
6.
What's 12 divided by 6?
2.
2. So I'm going to rewrite it just so it's clear what we have left here. What we have left on top is 6. Why don't I write the square root at all here? What's that? Yeah, this 6 is on the outside and this 6 canceled out. We really have a 1 left here, but we don't need that 1. Remember, when we have 1s, if we multiply by 1, it doesn't do anything, so we don't need that. On the bottom, we have this 2, but the 2 is on the inside of the square root. So we get that. All right, now what?
Then we multiply by the square root of 2.
Just the square root of 2? Yeah, so we need to multiply by the square root of 2 over the square root of 2. Okay, that's going to help us get rid of the square root in the denominator. So on top, we get what?
6 times the square root of 2.
And on the bottom?
2.
Just 2. So the square root of 2 times the square root of 2 is 2. We done? No, we got one more thing to do, right? Kind of like the last one, when we reduce the 15 with the 3, we can reduce the 6 with the 2, and we can actually divide those and get 3. So we end up with 3 square root of 2. This one's a little bit different. We're going to rewrite the problem to start with. So instead of having one big square root where the 1 and the 45 are inside the same square root, what can we do? Yeah, we're going to give each of those numbers their own square root. So this is the same thing as the square root of 1 over the square root of 45. Once we do that, once we give each of those numbers their own square root, we can simplify each one by itself. So we don't have any coefficients here to simplify, but we still need to simplify the radicands. How do I simplify the square root of 1? It's just 1, right? So the square root of 1 is 1. The square root of 45, well, can we factor that? Yeah. So this is going to be one of those that we can factor and pull out pairs. So the square root of 45, we factor and we get 9 times 5, 3 times 3. And so we rewrite it, we get the square root of 3 times 5.
Circle pairs. Then 3 goes on the outside and 5 stays on the inside.
Good. So we get 3 square root of 5, and that's going to replace the square root of 45, right?
Yes.
So when we say simplify the radicands, one way to simplify radicands is what we did here, and we reduce them. Another way to simplify a radicand is to factor it and pull out pairs. So here we're going to have the 3 square root of 5 down here where the square root of 45 was. So it's going to look like this. Then what do I need to do?
Then we multiply 5s on both of them.
Okay, now we have to get rid of the square root on the 5. So we're going to multiply by the square root of 5 over the square root of 5. So whatever that square root is on the bottom, we multiply it on top and bottom. On the top, what is 1 times the square root of 5?
Square root of 5.
On the bottom, this is a little bit trickier, but let's just take it one part at a time. The square root of 5 times the square root of 5 here, this whole thing is going to be what?
5.
That's 5. So then we multiply 5 times 3 and get 15. Notice that that 15 is on the outside of the square root.
Yes.
So can we reduce that with the 5 that's inside the square root on top?
No.
No. All right, so again, when we multiply the square root of 5 times the square root of 5, we get 5 without a square root. It's just a 5. We multiply by 3 and get 15. And then there's nothing to simplify here, so that's your final answer.